No, we want to put our battery over here. So what I'm going to do is I'm actually going to put back some material, um, but I'm not going to make it the same thickness. So what I'm going to do here is go to the very bottom. So this is the bottom of the plate, right? Actually, I'm going to do it on the top. I'm going to do it on the top. Yeah. So because the battery goes right here, we actually want this to be like sort of a solid, so that it doesn't fall through the floor of the chassis. And we're going to go sketch. We're going to sketch on the top here. We can select all of the outer edges, and we can hit convert. And now what we can do is we can extrude just that, but we want it going the opposite direction. We want it to be really thin. We want it to be like, I don't know, 1/16 of an inch. So, just enough that it will hold a battery, but now we've reduced all of this mass. So the reason why I put that pocket on the outside is because when you 3D print stuff, you always have to have a support underneath, and it's always nicer if you can print stuff without supports. Printing without supports is always good. It simplifies things so much. You don't have to do any cleanup. So that's why it's good to have all of these undercuts and overhangs and things on one side. So instead of having the pocket be on the opposite side, I had it on this side just so that then we don't have to print any supports. So I think you guys do have a large format 3D printer. At this point, you could literally take this STL and it just print it out. Yeah, it would work. So, but let's go back to the master assembly over here. So now we've got our chassis on the bottom. It will accept 1032 screws that will go all the way through. We've done some mass reduction so that we've gotten rid of a lot of material here. And if we really wanted to, we could also add zip tie insert holes. So when you're prototyping stuff, it doesn't really make sense to make things totally permanent. Zip ties are cheap, they're easy, they're pretty secure. Um, so all we have to do is we have to put a bunch of holes um, in the chassis now so that we can secure stuff with zip ties. So if this were a piece of metal, you could pretty easily make this out of you have a piece of sheet metal and maybe water jet cut these sections out, and then you'd have to mill pockets. So what the pockets would look like, because end mills are round. Let me show you. If you can kind of imagine the tool path of an end mill, they have a circular profile. So what you'd have to do is you'd have to put in the radiuses here. So you could do a fillet. You can click on the internal edge here, and I would make it pretty large. I'd make it like a 0.25. If you're removing a lot of material, you want to use a bigger end mill. So they would probably use a half-inch end mill here, and which has a radius of 0.25. See, I clicked the wrong. Here we go. Hello. There we go. So that would be more realistic, more like what it would look like. Now, if we wanted to add more fillets of that size, we can click on the fillet feature again, and we can go back and we can click right there, and we can click right there, and we can click right there, and right there. Nice. And yeah, we can go crazy with this if we wanted to. Um, Always makes your designs look a little more professional if you put fillets everywhere. So cool. Okay, so now that we've got all these fillets in place, let's put in the zip tie slots. So that'll be for like holding down the battery, holding down the electronics, and let's put down more of this thin plate. So let's do the same thing we did with that other plate over here. So we're going to sketch. We're going to hit N to get a normal view. We're going to select. Okay, never mind. I guess we have to do it individually. I think in SolidWorks that works. Alright, so here I have created the fillet, which is going to be annoying because then I'll have to select every single little curve, right? So what we should do is exit the sketch. Let's go back in time. Let's get rid of the fillet. So we're going to use the rollback bar. Now the fillets are gone. Now if I start sketching, it will put that sketch in after that point. So now what I can do is I can just select the lines, like way easier than selecting all the curves. And now I have to hit the convert button, project, nice. And now we can extrude these, and we're going to go in the opposite direction, and we're going to make it 1/16 of an inch. There we go. So now we put the rollback bar back. The rollback bar back. Wow, that's a friggin' tongue twister. So now we have fillets on the edges as we defined before. See, so we avoided having to select all this freaking fillets and add them to our our design here, our sketches rather. Oh, all right, I've lost internet. Another Achilles heel of Onshape. No internet, no CAD. All right, give me a second. Okay, and we're back. So let's take a look at what our assembly looks like now. So we're going to add in zip tie holes. So we're going to go view normal 2, and we're going to oh, actually, let me show you something. So if instead of just extruding the 1/16 of an inch, I could do up to face, and then I can reference the face that we already made. So if we do this, basically now, if I were to change the thickness of this face, these faces would also change in thickness. Whereas before, this was 1/16, and then these were 1/16 also. If I change this to 1/4 inch, these would stay at 1/16. So again, you just have to be thinking about design intent. If I change one thing, how are other things going to change? So let's continue here. We're going to go view normal 2, and now we're going to put our sketch in, and we're going to put our zip tie holes, which I have to go look up exactly what the size was. So let's go to hammer zip tie arm, and if you just click on edges, it will tell you the length. So 0.089 inches. That must be something that I told it in. Right. Okay. So see, because our default is the English system, Imperial. What we have to do is we have to click into the sketch, and we have to actually click onto the dimension. And you can see I physically typed 2.5 millimeters. So 2.5 mm's is what we'll do for that. And then this one is, how big is this? That looks like 8 millimeters. So 2.5 by 8 millimeters. Okay, gotcha. So let's go back over to the chassis. We're still in our sketch here. We're going to create a center point rectangle. We're going to go like this. We're going to do the dimension key. We're going to do 2.5 millimeters. We're going to do 8 millimeters. Nice. Okay, and now we can move this around. But let's say we want a whole bunch of these, right? Like just a ton. What we've got to do is we have to we could copy and paste this sketch, and it would get very annoying, and dimension all of them. Or we can use a linear pattern in a matrix. So in 2 dimensions instead of 1. We used a linear pattern earlier, but we're going to do it again here. So let's just dimension this so that we have clean numbers. 0.25 from the edge, sure. And let's make it 0.5 from the edge here. Nice. So we'll hit OK. And we're going to extrude that sketch. And it's going to be removing material, so hit remove. And sure, it goes all the way through, why not? And now we have our hole. And now we want to pattern this feature in a linear way. So first we want to pattern it this way, and then we want to pattern it down this way. And we can actually do both of those at once. So let's, you go to linear pattern, and we don't want part pattern, we want feature pattern. Once again, it makes no sense to have part pattern be the default, but I digress. And you click on your feature that you want to pattern, which was, extruding or removing material from this plate. We're going to click on direction. we're going to click on one of the directions. So this edge goes in the one of the directions we want, and then this edge goes in the other direction. Okay. So that's one direction, and we're going to flip this, and the distance is going to be shorter than that. We want maybe 0.25. No, that's still too short. 0.5. Yeah, it looks fine. And now we're going to pattern this. We want, I don't know, let's see how many we can fit in here. 5, 8. We can fit 8 in there. Okay. Now, second direction. We can click on second direction. Click here. And now it will pattern all of these as well. So let's do the distance here as 0.5. And our instance count, we want it to be, I think we can fit 4 in there. And it's in the wrong direction. You see how it's giving red? It looks like it's an error. Just hit this flip button, opposite direction. Yeah, good. Looks like we can fit a 5th one in here too. Actually, this distance looks a little bit too thin for me, so I'm going to take it back to 4 and increase the distance between all of them. That's pretty good. Maybe 0.7 is better. Nice. That looks pretty good to me. So now we have all of these, these little holes. This would be a nightmare to make in metal, unless you included it as part of your water jet process. So, designing for 3D printing is very different from designing for stuff you actually have to do the toolpath operations to make. Because a 3D printer doesn't matter if the part is complex or very simple. All the complexity of the moving head is, just figured out for you. Whereas if you had to, drill every single one of these little pockets, be really annoying. So, but luckily we're 3D printing this, and it's just for prototyping. So let's do the exact same thing except down here with our triangle. So we're going to go View Normal 2. And same thing, we're going to do Sketch. We're going to do Center Point Rectangle. We're going to put our rectangle in here. We're going to hit the D key. We're probably going to lose internet connection. My gosh. Yeah, see, like I live in the middle of nowhere, Maine, so my internet is not fantastic. Alright, give me a sec here. Okay, I'm back. Let's continue. Nice. Okay, so we're going View Normal 2. We're going to sketch. We're going to create our center point rectangle. We're going to make it 2.5 millimeters by 8 millimeters. We're going to drag it to a reasonable location. And now we're going to linear pattern. Oh, sorry, we're going to extrude this first. It's always better to pattern features than it is to pattern sketches. Try not to pattern sketches because it gets really hard to edit them. We're going to go remove. Looks good. Linear pattern. We're going to click on our extrusion as the entity that we want to, oh no, feature pattern. And the direction. And it always picks the wrong direction. I really don't know why. It's like a little curse. Little minor inconvenient curse. Yeah, 7 of them. Fits very well. And let's go second direction. I'm going to click down here. And 5 of them. Oh, okay, no, that was too... First of all, went in the wrong direction. And second, there's too many. And they're too far apart. That's maybe not far apart enough. Okay, so another difference between Onshape and SolidWorks is that with the linear feature pattern in SolidWorks, you are actually able to tell it which ones you do or do not want. So I would be able to click on all of these that are sort of outside the bounding box. I would click on this one, and I would be able to remove those before even creating them. But Onshape does not appear to have that feature. And basically what we have to do in this case is just build it by hitting that apply per instance, and now we can manually remove it. I think this is easier than manually drawing all those other ones. So let's go ahead and sketch here. And what I'm going to do is I'm going to try to select all of these. Pretty annoying, but sometimes you gotta do what you gotta do. Definitely a less elegant solution than what existed in SolidWorks, so once again, bravo Onshape. Let's keep clicking on lines. Good, good. And we're going to convert all of these, hitting that project/convert tool. Nice, so these are all sketches now. And now we're going to extrude them back. So we're going to add more material. So we're going in the opposite direction. And we're going up to face. And we're going up to this surface. That's the 1/16 that we took away. And we want to merge that. And we hit OK. And now we have filled back in all those little squares that should not be there. Nice. So now, instead of doing all that stuff all over again, because we made the part symmetrical, which is always smart, just to be easy, we're going to mirror pattern. Yep, mirror, feature mirror. We're going to click on both the extrusion and the pattern, and we're going to click on this extrude feature. We're going to select the midplane, which is this one, and you can see it's already flipped it all over. So you can select many features, and we should there. We should select all the features that we used to make that these holes. Very good. Nice. So let's just do some final cleanup. These square holes, they just kind of don't really make it look nice. Let's go ahead and add fillets to that. We can make them smaller fillets, 1/8 of an inch. Just click right there, click right there, click right there, and over there, and over here, and over here, and over here, and down here, and over here. Good, good, good. Alright, all done. Very nice. And let's look at this back edge here. So if we go into master assembly, everything will update. Very good. And let's for the heck of it, just put a fillet on the back, on this back edge here, because it seems like it could interfere with the wheels maybe. So let's go back to the chassis part, and we'll put in another fillet, and 1/8 seems fine. And I know this is not something you would do in a regular BattleBot, because this is actually a very hard feature to make. Really something you can only 3D print, because with milling pockets, you can imagine that the bit is perpendicular to the plate. With doing this outside radius, really hard to do. You'd need like CNC control computer, because what are you gonna do? You can't mount the plate lengthwise, like tall like this, and do a curve, because it would be way too tall. So just be cognizant of whatever feature you make. Think to yourself, how am I gonna make that? How am I, is this gonna be easy to make? Is it gonna be hard to make? That's something to keep in mind. So this is good. We've got a gearbox. We got a hammer. We got little wheelie bars on the back. We got space for our batteries. We got space for our electronics. We got space for our zip ties. And this looks like it can really swing. I'm actually pretty interested in what this will look like. You guys don't have to make this. It's just the first thing that I could come up with. That's like pretty simple and might be kind of fun. Put some holes in some walls. No, just kidding. Don't do that. All right. I guess that's kind of the end. So let me show you real quick. I don't know what kind of slicer you guys have for your 3D printer, but let me show you exactly how to 3D print parts. Um, oh, there's some sort of see this red error. I guess there's some sort of connector that's unsolved here, but honestly, this happens all the time. Sometimes if you remove them, it breaks everything. So just leave it in there. It's no big deal. If everything's behaving the way you want it to, there's no real need to fix stuff like that. Okay, so let's let's go back to trying to 3D print this. So what we should do here is we'll go to our part. So let's say we want to print the chassis part, right? Chassis part pretty important. So what we do is we hover over part, we right click, and we hit export. And you definitely want to name these in a versioned way. So chassis version 0.1. I use 0 as a version when I think that it's not done yet, or that I haven't made something of it yet. So I'll do 0.1, 0.2, 0.3 until I actually make it and change it, and then once it's been changed, I'll do 1.1, 1.2, 1.3. Just because sometimes you change the actual part multiple times in CAD before you actually make it. If you find you made a mistake or something like that. So um, keep everything here pretty much default. Okay, the units, millimeter, resolution fine, download, that's fine. STL is what you want, STL. So we'll hit OK. It'll ask you where you want to save it, and I'll just save it. Very good. And now, if you have a Prusa slicer, which is I have a Prusa. Ah, wow! It just barely doesn't fit on the build plate. Ah, that's such a bummer. Um, all right, no, this is a good teaching moment. Um, always be cognizant of your build limits. So if I know you guys have a large format printer, so I'm pretty sure you can print this part. But basically, what you'd have to do is you'd have to go back and change the part and edit it so that it fit on the build plate. See how it's kind of on the outside. But I think you could make it work. You just have to make it slightly smaller and a little bit shorter. But that's pretty easy to do. Maybe I can. I think you guys know enough about Onshape at this point. You could do that yourselves. But let's choose a different part because I want to choose something that actually fits on the build plate. Um, so let's go to the tails, the wheelie bars, and we're going to download this. So we're going to go to part down here, and we're going to do download or export. Very good. And these are tails in version 0.1. And hit OK. And now that's going to save. And I can open this with my Prusa slicer. Very good. And you can arrange the part, on the build plate. You want to print it so that the flat side is down and that parts do not have overhangs. And I'm sure you guys have a whole 3D printing protocol and everything, and I have different settings and such. And you slice it, you export the G code, you put it on the printer, and you print it out. And that should pretty much do it. That was sort of a little crash course in how to use Onshape, how to build stuff. You might need to build another part that actually attaches this onto the shaft better because actually, you know what, maybe we can do that right now. I think there should be a way to put a set screw in here, but basically this is not going to really stay on. You would have to design like something that goes on the end here. I think there's actually a screw. Oh, you know what? There is a screw. So these holes are usually threaded, and there's a screw that can go inside there, I think, and that will help you guys attach it. But I'll leave that as an exercise for you guys, or we can all brainstorm how to do that together, maybe over like a Zoom chat or something like that. Okay, excellent. So attach these with glue. There's really no point for putting fasteners in here. There's a whole bunch of 1032 screws lying around. I know that for a fact. They should fit in the gearbox. They should fit in those countersunk holes. Go buy some zip ties. Zip ties are awesome. And you should have all of these parts. And I guess when you guys have this all printed out, we can maybe I'll make a video or just help you guys on Zoom with actually plugging in the electronics and making this thing run. Okay, awesome.